Yo, Mr. Kaczynski here, working on skill number 2 in section double E of IXL's Algebra 1 sections, radical expressions. In my previous video, one prior to this, it was simplifying radical expressions. And in this one, we're just going to add variables into it, like that S right there. All right, so when we're simplifying radical expressions, what we want to do is look for perfect square factors of the expression that's in the radical. So for instance, 45 is divisible by 9. 9 times 5 is another way to write 45, where 9 is a perfect square. And then we also have the s to the 8th, which actually is a perfect square as well. We'll get to that in just a second. All right, so the square root of 9 is 3, and the square root of s to the 8th is s to the 4th. And because s to the 4th times s to the 4th is s to the 8th. And the square root of 5 is irrational, so we're just going to leave it as the square root of 5. And that'll be our answer as a simplified radical. 3s to the 4th times the square root of 5. All right, let's do this again. Again, we're looking for perfect square factors. 18 is also divisible by 9. Okay, so this time it's 9 times 2. And t to the 5th is not a perfect square, but if we expand it a little bit, like t to the 4th times t, which is still t to the 5th, then we get t to the 4th, which is a perfect square. So the square root of 3, or square root of 9 is 3. The square root of t to the 4th is t squared. And we still have inside the square root sign 2 and t. So that's our answer as a simplified radical would be 3t squared times the square root of 2t. This one's a little bit different because it's got that 7 in front. So let's start there here. We got the 7 times the square root. Is 12 divisible by a perfect square? It sure is, 4. 4 times 3 is 12, where 4 is a perfect square. And then we also have that t to the 9th, which t to the 9th isn't a perfect square, but t to the 8th is. Basically, you just need an even exponent, and you'll have a perfect square. Okay, so we've got the 7 times the square root of 4, which is 2, times the square root of t to the 8th, which is t to the 4th, all times the square root of what's left in there, the 3 and the t. Now this can be simplified just a little bit more though, because 7 times 2t to the 4th is 14t to the 4th, so it's just got that one extra step there. So 14t to the 4th times the square root of 3t. Couple more. 84. Well, I know that's divisible by 4, and that's a perfect square. So how about 4 times 21? And 21 is not divisible by any perfect square, so 4. W to the 10th is a perfect square. X to the 7th isn't, but if we expand it to, say, x to the 6th times x, okay, x to the 6th is a perfect square. So on this one, the square root of 4 is 2. The square root of w to the 10th is w to the 5th. W to the 5th times w to the 5th is w to the 10th. And the square root of x to the 6th is x cubed. X cubed times x cubed is x to the 6th. And then inside the square root sign, we still have the 21, and we still have the x. So 2w to the 5th, x cubed, times the square root of 21x. Let's do one more like that where it's got two variables inside the square root sign, and we've got this number outside, which makes things a little bit tougher. Last one here. So I'm going to leave the 9. Inside the square root sign, 147 is divisible by 49. 49 times 3 is equal to 147, where 49 is a perfect square. Now g cubed is not a perfect square, but if I make it g squared times g, I still have g cubed, and g squared is a perfect square. And h squared is a perfect square. So here's what we get on this one. We've got the 9. We're going to do the square root of 49, which is 7. So now it's 9 times the square root of 49. 9 times 7 times the square root of g squared, which is g, times the square root of h squared, which is h. And then inside the radical, we still have that 3 and the g, so the square root of 3g. Now outside the radical, we can obviously simplify. 9 times 7 times g times h is 63 gh, and times the square root of 3g. So 63gh times the square root of 3g would be a simplified version of this expression. What makes it simplified? The fact that inside the radical there are no perfect square factors. That's what makes it simplified. So that's simplifying radical expressions with variables. Good luck. Let me know how it goes.